Alright, so systems of equations substitution method. So another way to solve systems is by using the substitution method. There are 5 steps. The first step, you need to solve for one variable in any equation. The second step, put the solved variable from step 1 into the equation you didn't work with. Step 3, solve for the variable. Step 4, put the solved variable from step 3 into any equation. And then you're going to solve. If you get 0 equals 0 anywhere in there, that's infinite number of solutions. That means you have the same line. And if you get 0 equals a number, it's no solution. They're parallel lines. So for example 1, we're going to solve using the substitution method. So we need to solve for a variable in any equation. Now let's take a look at our variables. In the top one we have 7x plus 3y equals 4. And on the bottom we have 7 over 3x plus y equals negative 5. Now the bottom one is easier to work with because that y is already by itself. All we have to do is move over x. So that's what we're going to do. Alright, so now that we have one of the variables solved for, we're going to put the solved variable into an equation we didn't work with. So you notice we didn't touch the top one at all. So that's what we're going to put it into. And we're going to put it in as y because that's saying this is y equals negative 7 over 3x minus 5. So we have our equation of 7x plus 3y equals 4. So we have 7x plus 3 times y, which is our negative 7 over 3x minus 5, and that equals 4. Alright, so order of operations, we are going to distribute. So we have 7x minus 7x minus 15 equals 4. So then we get our x's cancel out, so we have negative 15 equals 4. Can negative 15 equal 4? No. So, no solution. Alright, example 2. We're going to solve for the variable using the substitution method. So we need to solve for a variable in any equation. So if we take a look at it, both are pretty simple to solve for. But for this example, I'm going to solve for y in the second equation. So we divide everything by 8, and we get y equals 9x plus 1. Okay, so what are we going to do with this one? We're going to put it into the equation we didn't work with as y. We have negative 9x plus y, which is 9x, which is 9x plus 1, and that equals 1. So you notice our x's cancel out, and we have 1 equals 1. Well, 1 does equal 1, but we can't go any further than this, so it's the same line, so it's infinite number of solutions. Alright, example 3, we'll actually get an x and a y for this one. So, for example 3, if we take a look at both of our equations, we need to solve for any variable in any equation. So the second one, we have x plus 7y equals 10. Well, that's the easiest to solve for because x is already by itself. We just need to move over the 7. Alright, so since we solved it, we're going to plug the solved variable into the equation that we didn't work with as x. So we didn't work with the top one, we're going to plug it in where x is. So we have negative 5x, which is negative 7y plus 10. And that is plus 3y equals negative 12. Now, step 3, we're going to solve for the variable. So we need to distribute. So we have 35y minus 50 plus 3y equals negative 12. So we got 38y minus 50 equals negative 12. Add 50 to both sides. We get 38y equals 38. Divide by 38. We get y equals 1. So now we're going to plug into any equation to find x. And the bottom one is the easiest one to solve for because x is already by itself. We just have to plug in y. So we have x equals negative 7y plus 10, so we have x equals negative 7 times 1 plus 10, so we have x equals negative 7 plus 10, or x equals 3. So the solution is 3, 1. Alright, next example. Now if we take a look at it, the bottom one again is easiest to work with because y is already by itself. We just have to move over the 7x. So now that we have that variable solved for, we're going to move on to step 2 and plug it into the equation we didn't work with as y. So we have negative 5x plus 3y equals 55. So we have negative 5x plus 3 times y, which is negative 7x plus 1 equals 55. So we're going to distribute to solve for the variable. That's step 4. So we have negative 5x minus 21x plus 3 equals 55. So we get negative 26x plus 3 equals 55. We're going to subtract 3 to both sides to get negative 26x equals 52. Divide by negative 26. We get x equals negative 2. Now, with that negative 2, we're going to plug it back into any equation to solve for y. So we have y equals negative 7x plus 1. So we have y equals negative 7x, which is negative 2, plus 1. So we have y equals 14 plus 1, y equals 15. So the solution... Alright, example 5. This one is a little harder to work with because if you look at both equations, not one of them is easier than the next one. So we just have to pick one and work with it. Now, I'm just going to work with the top one. It doesn't matter which one you work with. Again, just pick one equation, solve for any variable, and continue with the steps. So I'm going to work with the top one. We got 2x plus 3y equals 9. And here, I'm going to solve for x. So I'm going to subtract 3y. So we got 2x equals negative 3y plus 9 divided by 2. So we get x equals negative 3 over 2y plus 9 over 2. Now what we're going to do with that, step 2, we're going to plug it in into the equation we didn't work with as x. Alright, so we're going to plug in x for 5x plus 4y equals 5. So we have 5x, which is negative 3 over 2y plus 9 over 2. Plus 4y equals 5. We distribute. So we get negative 15 over 2y plus 45 over 2 plus 4y equals 5. Now we're going to do something here. It's called clearing fractions. We don't like working with fractions. So what we can do to clear the fractions, now you're going to multiply everything by the common denominator. And you notice here, all the denominators are 2. So we're going to multiply everything by 2. So we're going to multiply everything by 2. Remember, math is fair. So when you multiply it by 2, if you're multiplying by something and it has the same denominator, then it just cancels out. So when we multiply 2 times negative 15 over 2, the 2's cancel out, and we're left with negative 15y. Same thing for our 45 over 2, we're just going to be left with 45. So we get 2 times 4y is 8y, and 2 times 5 is 10. And now it's a lot easier to work with, no more fractions. So we're going to combine like terms. We get negative 7y plus 45 equals 10. We're going to subtract 45 to both sides. So we get negative 7y equals negative 35. Divide by negative 7. We get y equals 5. So what we need to do with that, we're going to plug it back into any equation to solve for the remaining variable, which is our x. So it doesn't matter which one you plug it into, I'm just going to plug it in to our first equation of 2x plus 3y equals 9. So we get 2x plus 3y, which is 5, equals 9. So we got 2x plus 15 equals 9. Subtract 15 to both sides. We get our 2x equals negative 6 divided by 2. We get x equals negative 3. So the solution... Alright, so moving on, we're going to have an application. It's very common to have applications when you have systems. So example 6, the sum of two numbers is 33. One number is 5 more than 3 times the other number. What are the numbers? Right, this is such a common word problem. I remember getting these back in grade school. So what we need to do is figure out what two equations do we have. So first of all, it says the sum of two numbers is 33. So that means we have two numbers, and when we add them together, it's 33. So our first equation is x plus y equals 33, right? X being one number we don't know, and y being the other number we don't know, because they're two separate ones. You can use a, you can use b, but it's common to use x and y. So our second equation states that one number is 5 more than 3 times the other number. That's the tricky part. So it's saying one number we have, we don't know what it is, so it's x, that's equals 5 more, so 5 more than 3 times the other number. So the other number is 3 times y. Now we have our two systems. We can use our substitution method to figure it out. And look at that. We already have x solved out for us. So we're going to plug in x to the first equation because that's the one we need to substitute it into. So we have x, which is 5 plus 3y plus y equals 33. So we have 5 plus 4y equals 33. We're going to subtract 5 to both sides. So we get 4y equals 28. Divide by 4. We get y equals 7. Now what we're going to do with this one, we're going to plug it back in to find x. So we're going to use the bottom one because x is already solved for. So we have x equals 5 plus 3y. We have x equals 5 plus 3 times 7. So we have x equals 5 plus 21, so x equals 26. But anytime that you have a word problem, you need to answer using a sentence. So we have the numbers. Alright, so that's it for the video. But along with this video, I put in the PDF of the notes, and at the bottom of the notes, I have extra problems for you to work at on your own, and then at the end, I have the answers and how to work them out. So I highly encourage that you do those next examples on your own, and if you have any questions, leave them in the comments.